Okay, good afternoon, everyone. My name is Xin from ReHAR University. My advisor, Professor Chuah. In this paper, we propose a robust and efficient human activity recognition. We call it ReHAR. And the motivation is that the human activity recognition method can be used in many different application scenarios. For example, the video retrieval for public safety, or even to analyze the sports videos. So we believe that having an efficient scheme to quickly identify the human activity from videos is very important. This is the overall framework of our proposed method. The most left part is the input video frame, RGB frame. We first use FlowNet to generate optical flow and use CNN1 to extract visual feature from these generated optical flow images, and use CNN2 to extract visual feature from the input RGB frames. And then we feed these visual features to a global average pooling layer and a global maximum pooling layer. And then we use a LSTM model to learn a representation for every single video, and use a fully connected layer to generate a probability distribution of the current frame among all the possible activity label. And after that, we use another LSTM model to infer the final activity label. So in this case, we have two kinds of output. The first kinds output is the distribution is the probability distribution of the individual frame, which we marked the loss one, and the second output is the final prediction. So the total loss is the sum of these two parts. The first one is the sum of the individual prediction loss, and the second is the final prediction loss. And the lambda here is used to balance these two parts. Next, we will show some experimental results. We use two datasets. The first one is the basketball dataset. As this table shows, our model achieves the best accuracy compared to other existing methods. We want to highlight that in paper 8, Fei Li and other authors propose a method to detect and tracking players to infer the activities, but they only achieve like 51 accuracy. We achieved 7% improvement. There is another very interesting observation. If we group 10 shooting-related actions into two categories, like shooting successful or shooting failure, there are 88% testing samples are correctly labeled. In this case, this means that our model has the capability to analyze the whole video and extract useful feature from the global features to predict such details. Okay. The second dataset is the UCFSports Action Dataset, and as the results shown in this table, our model achieved the best accuracy and at least have a 6% accuracy improvement. And we noted that there are 6 out of 10 categories we achieved 100% accuracy. And next, we want to try to explain why does the proposed model works. And this is our, okay. First, our model achieved 98 accuracy on UCFSports Dataset. If we replace all global pooling layer with flatten layers, we get a little bit worse accuracy. But if we replace the LSTM1 layer with the convolutional layer, we only get 76 accuracy. But if we replace it with the element-wise sum, we get even worse. So in this case, we believe that LSTM1 indeed learned some useful, some distinguished features for this task, and the global pooling layer helped improve the accuracy. We also visualize the learned network trying to understand what kind of features the model learned. And welcome to stop by our poster. We will show more visualize the result and discuss.